we're now going to look at another question on equilibrium. This was taken from the Gauteng Education Department's prelim preparatory exam from 2011. So, what do they tell us? 10 moles of SO2, 4 moles of O2 are put in a sealed container at 450 degrees of an unknown volume. The volume rather is neither here nor there at this point. When the reaction represented by the balanced equation below reaches equilibrium, it is found that we have 6 moles of SO3 present, and they give us a nice balanced equation. We like that, yay. And delta H is negative, so what they're telling you is the forward reaction is exothermic. What does dynamic equilibrium mean? Okay, it's when the rate of the forward reaction is equal to the rate of the reverse reaction. Straightforward. It's when the rates are equal. Now we get to the fun question, because now they tell us, calculate the volume of the container if my Kc value is 4,44. Before we have a little bit of a moment ago, I don't know how to do that. This is the key. They gave us information before equilibrium was reached, and then they gave us information when equilibrium was reached. Then they gave us the Kc value. Because of that, I know I need to use the table. Okay? I know I'm going to need to set up the table. So that's what I'm going to do. So we have, probably need that a little bit longer this time, our ratio line, our initial line, change, equilibrium moles, equilibrium concentration. We need a column for SO2, we need a column for O2, and then my last column is my SO3. Okay, and here's where my it changes. Products to reactants to products. SO2, O2, SO3, and we know that this is the ratio. This is my initial. This is the change. This is my final, equilibrium, not final. Otherwise it doesn't spell ice or rice. And then this is my equilibrium moles per decimeter cubed. Now I'm going to write in everything I know. So they said to me I had 10 moles, and we had 4 moles, and then at equilibrium we have 6 moles. Okay, we put in our ratio, so that's 2 to 1 to 2, and we always know, because there's no exception, that SO3 is 0. And we remember that we add to the reactant, so we fill in the rest of this, and we go, I didn't have any SO3, and I've ended with 6, so I made 6. Now I'm going to use the mole ratio, so I'm going to go 6 times by 2 divided by 2 gives me that one, so it's 6. 6 times by 1 divided by 2 and gives me 3. So I make sure that the ratio and the change lines are same ratio. So 2 to 1 to 2, 2 to 1 to 2. Then I had 10 moles of SO2. I used 6, so now I've got 4. I had 4 moles of O2. I used 3. Now I'm left with 1. This is the trick to this question. They wanted to know what the volume was. We didn't know the volume. But at this point, we need to change the number of moles into a concentration. And concentration is number of moles over volume. So I can go 4 over my volume, 1 over my volume, 6 over my volume. So I've got an unknown. And that's okay because I know what my Kc value is. Alright? So look, Kc is SO3 squared, oopsie, over SO2 squared times O2 squared. They said to me that the Kc value was 4,44. So I know that this is going to be 4,44, 6 over v squared, divided by 4 over v cubed, and 6 over v. Okay? Well, when we look at that, and I'm not going to do all the maths, now it's solving for v. That's what this is now. That's where you go. Now it's about solving for v. So we're all happy because it's not that difficult. Well, some of you will struggle, doesn't matter. If you can't get to v, it's 1 mark. 1,97 decimeters cubed. Really? It's okay, we can do this. Then they say, how will each of the following changes affect the equilibrium constant? Right, only increase, decrease, or remains the same. Now, first of all, they add more SO2. SO2, the concentration and pressure have absolute, and a catalyst cannot change the Kc value. So this one remains the same. The temperature is increased. It cannot stay the same. Here we've got to look at it carefully. Now, the forward reaction is exothermic. If I increase the temperature, I'm going to favor the endothermic reaction, which is the reverse reaction. So I'm going to increase the amount of product. Increase the amount of reactant. If I have more reactant, the bottom of my equation gets bigger, which means my value gets smaller. So it's going to decrease. Alright, this is why. The reverse reaction is favored, or the reverse reaction is endothermic. Let's just put it all the detail we need. An increase in temperature will favor the reverse reaction. Therefore, more reactants will be made. Okay, not so bad.